An electrical grid is an interconnected network for electricity delivery from producers to consumers. Electrical grids vary in size and can cover whole countries or continents. It consists of power stations, often located near energy and away from heavily populated areas. Electrical substations to step voltage up or down. Electric power transmission to carry power long distances. Electric power distribution to individual customers, where voltage is stepped down again to the required service voltages. Grids are nearly always synchronous, meaning all distribution areas operate with three-phase alternating current AC frequencies synchronized so that voltage swings occur at almost the same time. This allows transmission of AC power throughout the area, connecting a large number of electricity generators and consumers and potentially enabling more efficient electricity markets and redundant generation. The combined transmission and distribution network is part of electricity delivery, known as the power grid in North America, or just the grid. Electricity generation is the process of generating electric power from sources of primary energy, typically at power stations. Usually this is done with electromechanical generators driven by heat engines or the kinetic energy of water or wind. Other energy sources include solar photovoltaics and geothermal power. The sum of the power outputs of generators on the grid is the production of the grid, typical measured in gigawatts. Electric power transmission is the bulk movement of electrical energy from a generating site via a web of interconnected lines to an electrical substation, from which is connected to the distribution system. This networked system of connections is distinct from the local wiring between high voltage substations and customers. Because the power is often generated far from where it is consumed, the transmission system can cover great distances. Substations may perform many different functions but usually transform voltage from low to high, step up, and from high to low, step down. Between the generator and the final consumer, the voltage may be transformed several times. The three main types of substations by function are: step-up substation. These use transformers to raise the voltage coming from the generators and power plants so that power can be transmitted long distances more efficiently with smaller currents. Step-down substation. These transformers lower the voltage coming from the transmission lines, which can be used in industry or sent to a distribution substation. Distribution substation. These transform the voltage lower again for the distribution to end users. Circuit breakers, used to automatically break a circuit and isolate a fault in the system. Switches, to control the flow of electricity and isolate equipment. The substation busbar, typically a set of three conductors, one for each phase of current. The substation is organized around the buses and they are connected to incoming lines, transformers, protection equipment, switches, and the outgoing lines. Lightning arresters. Capacitors for power factor correction. Distribution is the final stage in the delivery of power. It carries electricity from the transmission system to individual consumers. Substations connect to the transmission system and lower the transmission voltage to medium voltage ranging between 2 kV and 35 kV. Primary distribution lines carry this medium voltage power to distribution transformers located near the customer's premises. Distribution transformers again lower the voltage to the utilization voltage. Customers demanding a much larger amount of power may be connected directly to the primary distribution level or the subtransmission level. A microgrid is a self-sufficient energy system that serves a discrete geographic footprint, such as a college campus, hospital complex, business center, or neighborhood. Within microgrids are one or more kinds of distributed energy, solar panels, wind turbines, combined heat and power generators that produce its power. In addition, many newer microgrids contain energy storage, typically from batteries. Some also now have electric vehicle charging stations interconnected to nearby buildings. The microgrid provides electricity and possibly heat and cooling for its customers, delivered via sophisticated software and control systems. A microgrid is local. This is a form of local energy, meaning it creates energy for nearby customers. This distinguishes microgrids from the kind of large centralized grids that have provided most of our electricity for the last century. Central grids push electricity from power plants over long distances via transmission and distribution lines. Delivering power from afar is inefficient because some of the electricity, as much as 8 to 15%, dissipates in transit. A microgrid overcomes this inefficiency by generating power close to those it serves. The generators are near or within the building, or in the case of solar panels, on the roof. A microgrid is independent. A microgrid can disconnect from the central grid and operate independently. This islanding capability allows them to supply power to their customers when a storm or other calamity causes an outage on the power grid. In the US, the central grid is especially prone to outages because of its sheer size and interconnectedness, more than 5.7 million miles of transmission and distribution lines. As we learned painfully during what's known as the Northeast Blackout of 2003, a single tree falling on a power line can knock out power in several states, even across international boundaries into Canada. By islanding, a microgrid escapes such cascading grid failures. Conventionally, a grid is an electricity network that connects power plants, the infrastructure composed of wires and poles, and the consumers, industries, business establishments, and homes. A macrogrid is either government-owned or privatized. If you own a solar and battery storage system that is connected to the macrogrid, you can consume energy from the grid itself. You can also send energy into it. This grid system is resilient and largely, a macrogrid connects consumers to a central power source, which means that in a power outage, everyone connected to the network is cut off from the energy source. This is all about Power Grid. See you in another video. Thank you. This video is by Niriksha, Sagar, Sinchana, Ramanpreet and Vikram.